So we have 6 volunteers doing the iOLight work. They're strategically located in 6 regions around the lake. That happens weekly during the summer. Every Tuesday we do this, and we kind of have a chain working up a kind of a relay, working up each side of the lake, and they all get dropped off at the office and they're overnighted to SUNY ESF to Greg's lab there. So this is a sampling pole, and the design was given to us by a gentleman who's a volunteer on Canandaigua Lake named Bill Ebert, who obviously is an engineer. It's basically a strap wrench attached to a screw-on handle attached to a reaching pole. So the water we collect in this jug will be filtered through a 52 micron Nitex mesh, and then we'll take a couple of drops of the concentrated phytoplankton and look at it under the iOLight microscope. And now we can take that jug of water and see what we find in it. This is a 52 micron Nitex mesh. And by pouring this jug of water, lake water through it, it will concentrate the phytoplankton community. And then we'll take 2 drops of that and put it on a microscope slide and see what we've got. You know, we have seen the algal community change over the season, just like it's supposed to. We had a lot of diatoms, we've had a lot of golden algae, and we have noticed over the last 6 weeks that microcystis is the dominant phytoplankton in the water drops that we're looking at. I expect when we finish pouring this through there, we're going to see some green collected at the bottom of the mesh. So microcystin, the N, is the toxin that microcystis and some other cyanobacteria produce. It is super easy to use. It is a 400X. It has its own Wi-Fi signal, so this can be done in the field without cell service or power. I'm going to go in to my sample, and I'm going to try to get that concentrated bit there and drop a drop or 2 onto the microscope. The first image, it's all microcystis. So I do kind of a little bit, that's all microcystis. We have some zooplankton moving around in there, but all of these groups of tiny dots are microcystis colonies. It's a zooplankton.
And it's moving.
It is moving.
Okay.
What I can do when I find something of interest, I can take a photo of it on my phone here, and then later we upload these to Greg at SUNY ESF. Our lake doesn't have just Microcystis aeruginosa. Greg has identified 2 other strains of Microcystis that he was actually quite surprised to find them in Canandaigua. The other thing that we're looking at is, are we seeing changes in phosphorus and nitrogen, and comparing what's going on to the algal community at that point in time. You know, we're doing all this work basically at the end of shoreline or end of dock, and we'd like to compare the nutrients to some of the sampling that the Watershed Council and FLCC are doing mid-lake or at our CSLAP locations mid-lake. There is a lot of work that's being done. I'm glad that we can be a part of it in advancing the understanding of what causes it. And because until we understand that, we really can't do anything to mediate it. Climate change, the heating up of lakes and lake water, nutrient runoff, that all contributes. But I think quagga mussels probably have a role to play. They tend to graze on non-cyanobacteria, and when they get it in their system, they spit it out. And you know, the net effect of that is that the good algae is eaten and the microcystis is left remaining, which could be why it concentrates into a bloom. What historically has happened within watersheds, whether it's industrial, whether it's agricultural, you know, Seneca Lake has challenges with the salt mines and the Bitcoin mining. So everybody has unique inputs. I think something that has been really interesting to me is Honeoye, for instance. They have blooms starting very early in the summer, but they're not toxic. Our blooms, as we've witnessed, this year and last, we haven't had very many. We did have a lake-wide one a couple weeks ago, but our blooms tend to be highly toxic. So one of the things that through a research project with Dr. Lisa Kleckner at Finger Lakes Institute, Hobart, William and Smith, and Dr. Ruth Richardson at Cornell, they did a study that compared Canandaigua versus Cayuga, and the ratio of chlorophyll A to the microcystin level was much higher at Canandaigua than it was on Cayuga. We don't know why that is. And, these are really interesting questions about trying to understand why that's happening. What is unusual about Canandaigua is that we are, in fact, a low nutrient lake. I think Skinny Atlas is in that group as well. We shouldn't, by all standards, be experiencing the harmful algal blooms that we are. And so we're trying to get at the bottom of that. Well, we certainly are always looking for shoreline monitors for harmful algal blooms, but it's just fun to do. If people have an interest of, bringing in a liter of water and running it through a filter, I'm sure we could arrange that and let them look at what they can find in the water.
That's awesome. Well, thank you, Sally.
You're welcome.